Open your books to page 253. We're still talking about lesson 17.1, which is solving systems of linear equations by graphing. So we're going to start with question 9. So we're going to graph these two equations and see whether they have one solution, no solution, or infinitely many solutions. And if I look at both of these, they're already in slope-intercept form. Y equals mx plus b. So y is completely by itself, or solved for. It's alone. So I don't have to do any work in the beginning. So all I have to do is start by plotting my y-intercept down at -10. And then my slope here is a positive 2 over 1. So I'm going to rise 2 and run 1. And because this is a positive slope, I want my line to be increasing. So up 2 over 1. And then use a ruler or a straight edge, and I want you to connect all of these points. And then my second line, I have a y-intercept at positive 5. It's my b value on my y-axis. And my slope here is a -3 over 1. And so this line needs to be decreasing or declining. So down 3 over 1. Make sure you're plotting as many points as you can on this graph before you use your ruler to connect them, because you never know where they're going to intersect. And then there is my intersection point. So because they intersect once, that means I'm going to have one solution, and we need to write the solution as an ordered pair, and it's always x. That comes first. So how many did I move left or right? So I went right to, looks like a positive 3, and then I went down to -4. So this would be my solution. So what that means is when I plug in 3, -4, it makes both equations true. So 3, -4 is the intersection point. That's the answer. Okay, question B represents a story problem talking about Edgar having nickels and dimes. That's why they use N for nickels, D for dimes. And notice on your y-axis it's labeled D. So we need to solve both of these equations for D. On your quiz, I always give you X's and Y's, so you don't have to worry about it, unless it's like a story problem, maybe. But it'll be clearly labeled for you. So let's do this first one. In order to get this D all alone, we need to move the N to the other side. Make sure you're showing your work. Okay, I've seen some common mistakes where if I subtract N, I forget to write the negative out in front, and then it changes my answer. Okay, so my y-intercept here, everybody go up and we're going to plot it at 9. And then my slope here is a -1. So we're going down 1 over 1, down 1 over 1. Because it's negative, we want our line to be decreasing, thinking about sledding down a hill. We're going down. And then use a straight edge to connect these. And then my second equation, subtract. We want to get 2d by itself, so we're going to subtract n. So 2d equals negative, don't lose the negative, n plus 11. Divide everything by 2. Ooh, this doesn't look very good. So d equals negative, I can't just say negative 2n, which some of you are trying to write. There's a 1 here, so negative 1/2 n plus 11 over 2. What is 11 over 2 as a decimal? Where would I graph that on my number line? 11 divided by 2 is 5.5 or 5.5. So this graph is a little tricky. So let's go up to 5.5. And then we're going to go down 1 box, right? Because my slope is a negative 1 over 2. Down 1 box over 2. Down 1 over 2. Down 1 over 2. Let's see how this is going to work out. So I'm going to use a straight edge to connect this. Up 1 over 2. And if my first line was a little bit straighter, except I didn't use a straight edge for this first line, this should be our intersection point right here. And that occurs at x value of 7, 2. So hopefully yours looks close to 7, 2. And I think the book is doing this to show us that maybe graphing doesn't always work, or the graphing method maybe isn't always the best option. So let's look at question C. Both of these on the top of page 254, both of these are in slope-intercept form. So the first one, I'm down at a -5 for my y-intercept on my y-axis. I have a positive slope of 3 over 1, so this line is going to be increasing or inclining up 3 over 1, up 3 over 1, up 3 over 1. Go ahead and use a straight edge and connect these. Remember to put as many dots on your graph as possible. Use a ruler or something straight when you're connecting them. A common mistake that I've been seeing is that we're flipping or switching our rise over run. Okay, our rise is our change in y values up and down. Our run is side to side. And another one that I've been seeing is we're forgetting that our positive slopes have to be increasing or rising from left to right, and our negative slopes have to be decreasing or declining from left to right. So my second equation has a y-intercept of positive 4, my y-axis, and I'm going down 2, it's my rise, down 2 boxes over 1, down 2 over 1, and then I'm going to go up 2 over 1 the other direction. And I didn't really have 2 coordinate points or 2 dots overlap or intersect each other. Alright, I'm going to go ahead and use a ruler and connect these. And this is not a good intersection point at all. It's a decimal. Right? Like, not quite 2, and not quite a half. Here's what the teacher edition says. Yuck. So, clearly, graphing is not always the best method because there's not an intersection point here. Let's move on to question D and see what happens. So I'm going to take this one and rewrite it so we can convert it to slope-intercept form. So we need to solve for y. So let's subtract 3x from both sides. Do not lose your subtraction sign or your negative with the 3x. Then it's a positive or a plus 1. So start at, actually before I even graph this, I'm going to go ahead and solve the second one. So 6x plus 2y equals 10. Uh-oh. Something just happened. Okay. Just got disconnected, but I think we're back, so hopefully you can see this. So I want to get 2y by itself. So subtract 6x, subtract 6x, 2y equals, don't forget about that negative with the 6x, then plus 10. Now I want the y by itself, so that means I want to divide both sides by 2. These cancel. Y equals negative 3x plus 5. So if I'm looking at both of my equations, I notice something is the same. My coefficient in front of the x. They both have a slope of negative 3, which means these are going to be parallel lines. I'm going down 3 over 1 for both of these. So if they're parallel lines, they're never going to intersect or touch. So how many solutions do we have? This is going to be a no solution answer. And I didn't use my ruler here, so these aren't perfectly straight. But we know from activity 12 that the slopes of parallel lines are the same, so they never touch, they never intersect. So the answer here for this would be no solution. Okay, so question E says, what made finding the solution to parts C and D challenging? Well, it's difficult to estimate answers or solutions that are not integers or whole numbers. Right, for question C, we had like a decimal or a fraction. And then for question E, there was no intersection point when the lines are parallel, when they have the same slope, so there's no solution here. Okay, then on page 255, in the check your understanding box for 11A, B, C, and D, the book wants you to graph all of those, and again, they don't give you graphs, so we are actually going to skip those because we spent a lot of time on Tuesday graphing. So if you haven't finished the worksheet from Tuesday, questions 1 through 8, make sure you finish those graphing questions and turn them in.